So let's discuss some of the questions of chemistry asked in JEE Mains April 2025. So first question is designate whether each of the following compounds is aromatic or not. So for compound to be aromatic or not, it must have three rules. First is compound should be planar, that is we can draw it in a plane. Next should be complete delocalization of pi electrons, which means as in benzene ring we know that the electrons are not fixed, that is they are delocalized, that is electrons keeps moving around a circle. Next is presence of 4n plus 2 pi electrons. For example, if we compare it with benzene, it has 6 pi electrons. How does it have 6 pi electrons? Because there are 3 pi bonds, and since there are 3 pi bonds, number of bond in one number of electrons in one bond is number of electrons in one bond is 2, therefore 3 pi bonds will have 6 electrons. This rule is known as Huckel's rule. So we have to know whether the compounds given above are aromatic or not, so it must follow those three rules. So let's compare the first one. How many electrons does it have? It have 2 4 6, so 6 pi electrons, so A might be aromatic. Next is B have only 4 pi electrons, so B is definitely not there. C has 2 pi electrons, it can have, for example, 4n plus 2, that is if n equal to 0, then we can have 2 pi electrons. Next step is D can also be taken as aromatic because it has 6 pi electrons. Next up is E can also be aromatic because it has 6 pi electrons. F has 8 pi electrons, G has 4, and H has 2. So let's see whether any of the options have A, C, D, E, and H. So we can see that option 4 matches the answer, so it is aromatic. BFG are not aromatic. Also we can conclude that all are planar since they can be drawn in a plane and delocalization is there in everyone. Okay, and also from options we can see that EG more than one, EG, BFG, all options will not get matched, therefore only one option is correct. Next question is an optically active alkyl halide formula is C4H9Br reacts with hot KOH. So let's try optically active alkyl halide C4H9Br. So C4H9Br can have C4H9Br. So for it to be optically active, so for C4H9Br to be optically active, the bromine must be on this carbon, and you can think of other ways of getting bromine, but the thing is it is not optically active. And how do we get an optically active alkyl halide? In optically active halide, the carbon attached to halogen must have all four atoms different, that is here it is methane, here it is ethane, here it is hydrogen, and here it is bromine. Since all four compounds are different, therefore option should be this, that is 2-bromo-butane, it is A. Next is it reacts with hot alcoholic reacts with hot KOH dissolved in alcohol. So KOH dissolved in alcohol, that is alcoholic KOH. So we know that from alcoholic KOH we get a double bond. Had it been aqueous KOH would have been given us this one, that is butane 2-ol. So we have B till here. So we started with A, then we went till B. Next up is B as major product, which reacts with bromine to give dibromide and forms alkene B as major product, which reacts with bromine to give dibromide. Acha. So after reacting with bromine it gives dibromide. So the only option will be this, that is Br attached to second and third carbon. What will be its name? 2,3 dibromo butane. Next is the compound is converted into gas D upon reacting with alcoholic NaNH2. On reacting with NaNH2. So as long as I can remember, on reacting with NaNH2 it gives but to wine. During hydration 18 gram of water is added on warming with mercuric sulfide at 333 Kelvin to form compound E. So on giving water HgSO4 at 333 Kelvin, so water does only hydration, so on an OH atom is attached, OH molecule is attached. So what does this do is a rearrangement, that is the double bond gets transferred to here. So here we get a double bond O. So this is the final answer E. What is this? Butane 2 on. Let's see if any of the options is correct. Yes, option 3 is correct. So the correct answer will be option 3. Correct answer will be option 3, butane 2 on. Let's see one more time. Optically active alkyl halide having formula C4H9Br. We can only have this one, since the other halides, if you try, are not optically active, because in optically active halide the carbon atom should have different molecules attached. On reacting with alcoholic KOH, because in the question only it was written, it reacts with hot KOH dissolved in ethanol. So alcoholic KOH gives a alkene, whereas aqueous KOH would give a OH, alcohol. Aqueous means water. In water OH is added. Alcoholic KOH we get elimination. On addition of Br2, it is written it gives a dibromide. In the question is only written. So we get 2,3 dibromo butane. Then NaNH2, Na in NH2, we know that it gives an elimination reaction, that is forms a butane. Butane hydration. After butane, if we do a hydration, what happens is OH gets added. Then there is a rearrangement because ketoenol form, because the keto is more stable. The answer is E, that is butane 2 on. I hope you all understand. Next is properties and properties that show irregularity in the first four elements of group 17 are. So the first four elements of group 17 are group fluorine, chlorine, bromine and iodine. So let's see covalent radius. Down the group, covalent radius increases, so there isn't any irregularity. Electron affinity, as long as I can remember, chlorine has higher electron affinity than fluorine. Why? Because due to small size of fluorine there is electron repulsion. That's why what happens when fluorine gets to F minus, the electron which comes gets repelled by the small size of fluorine. Therefore it is difficult for fluorine to accept a pair of electron, whereas for chlorine, because of its greater size, it can easily accept a pair of electrons. So there is a irregularity here. Ionic radius, down the group size increases. First ionization energy down the group, as size increases, ionization energy should also increase. And I am also discussing about electronegativity. Electronegativity down the group decreases, that is fluorine has higher electronegativity, iodine has the least. So what answer is correct? Only B shows irregularity. Next is, which of the following graph correctly represents the plot of KH at 1 bar in a water versus KH versus temperature plot. KH versus temperature plot. So what is KH? If you remember Henry's law of solution chapter of class 12th, Henry's law state formula was P equal to KHX. That is, greater the pressure, greater will be the solubility of a gas in a solvent. That is, greater the pressure, greater will be the mole fraction of the gas in the solvent. For example, in soda water bottles, CO2 is put in high pressure. That is why CO2 gets dissolved, giving it a fish sound when we open the container, since the pressure inside is greater, and when we open it, the pressure equals to the atmospheric pressure. Now we know that P equal to KHX, and we have to know the plot between KH versus temperature. Now KH, since these are, we are putting it in multiplication, KH into X, greater the value of X, less will be the value of KH. That's definitely, it must be true. P equal to KH into X, greater the value of X, less will be the value of KH. That is, they are inversely proportional. Now let's see the graph again. KH versus temperature. So the first graph we see solubility rising versus temperature then decreasing. So let's again discuss what happens to KH versus temperature. So KH versus temperature. As temperature increases, solubility must decrease. As temperature increases, the gas evolves, so solubility decreases. But it's also said that greater the temperature rise, that is, at first solubility decreases, that is, solubility versus temperature. If I say X versus temperature, solubility first decreases, then as temperature rises, solubility increases. So KH must be opposite. KH must first rise then decrease. since solubility and x are inversely proportional. Therefore we have to find a graph where the kh is first rising, then it is decreasing. So it happens in question in option 1 and option 4, where it is first rising and then decreasing. Then let us see the gases helium, nitrogen and CH4. Here it is oxygen, nitrogen and helium. So how will the KH vary? So for them KH depends on solubility. If we compare the gases helium, nitrogen, oxygen, and the other gas was say CH4. So helium is a noble gas. Solubility of noble gas must be least. Since solubility of noble gas is least, its KH must be highest. So let's see the option in which helium is highest. Helium is highest in option 4. So the correct answer is answer 4. Let's again discuss from the graph whether we have correct answer or not. We have to guess the graph where KH versus temperature plot is given. Since P equal to KHX, greater the mole fraction, less will be the value of KH. As I have said that KH versus temperature, KH since mole fraction versus temperature, since mole fraction first decreases with temperature then increases, therefore KH must first increase then decrease. Therefore option 4 is correct there. And also for gases, since helium is a noble gas, it must have least solubility, therefore maximum value of KH. Therefore answer 4 stands. Next is, according to Bohr's model of hydrogen atom, which of the following statements is incorrect? Radius of third orbit is 9 times larger than of first orbit. Radius of eighth orbit is 4 times larger than of fourth orbit. Let's see the value of formula of radius. So radius of Bohr's orbit is r equal to a0 n square by z. Also energy is minus rh z square by n square. The value of RH is minus 2.18 10 to the power minus 18. So only radius is asked. So first question is radius of third orbit is 9 times larger than that of first orbit. Radius of third orbit is third orbit is 3 square by z, that is 9. So it is 9 times larger than the first orbit. So statement first is correct. Radius of 8th orbit is 4 times larger than that of 4th orbit. So radius of 8th orbit n square, that is 8 square, and 4th orbit is 4 square. 64 by 16, it comes to 4. So it is correct. So option 2 is also correct. Let's see option 6, third. Radius of 6th orbit. 6th orbit is a0 n square by z, that is 6th orbit 6 square. 4th orbit 4 square, 36 by 24. It doesn't have 3 times. So third is incorrect. The question is asked which is incorrect. So third answer is correct. So that's all. Thank you.